Let's take a look at one more. In this last one, we've got, again, two graphs. We'll start out with the first one. 6x minus 4y is less than or equal to 10 first. Well, most students would say, let's put it in slope-intercept form first if we want to graph it. So we'll subtract the 6x from both sides. That's a good way to start. And that would give us a negative 4y is less than or equal to negative 6x, and we've got a positive 10, so plus 10. And continuing along, we divide both sides by a negative 4. Be careful. Remember, when you divide both sides by a negative, it will flip the direction of the inequality. So now we'll be looking at y is now, be careful, greater than or equal to, what do we have on the other side? We have a negative 6 divided by a negative 4, which will actually become a positive. Also, 6 over 4 does reduce to 3 halves because they're both divisible by 2. And we'll have our x. On the second part, we've got a positive 10 divided by a negative 4, a positive 10 divided by a negative 4, which will give us a negative 10 fourths, but again, that reduces as well. They're both divisible by 2 and will reduce to negative 5 halves. So we can graph this one. We'd start out with, just like before, we'd start out with our y-intercept first, which is a negative 5 halves. Well, if you use your calculator to figure out what negative 5 divided by 2 is, you'd figure out that it is negative 2.5. So that means you'd go down on the y-axis to about negative 2.5. Okay, and then you would use your slope, which is 3 halves. Remember, you have your slope, which is 3 halves. That's your rise over your run. Because your rise is positive, you'd be going up 3. Your run is also positive. You'd be going left 2. So up 3 would mean you're going up 3. You're going to stay in the middle, though. 1, 2, 3. And then we're going to go right 2. 1, 2. So we're going to go up 3 to the middle and right 2 to the middle. And I know it's not quite easy to see, but it will still be a little bit in the middle here. And so the question is, what kind of line are we going to draw? Well, the symbol is what's going to tell us. Remember, it's a greater than or equal to, which means our line is going to be a solid line. So we can go ahead and draw that. Remember, I don't want to shade down here, though, because that's my final graph. I need to see what's going to overlap. So I'm also going to draw the same graph over here on the left on a little mock-up. Again, remember to graph it. I went down to around negative 2.5. And then I went up 3. 1, 2, 3. And then over 2. 1, 2. And we drew a solid line because of the equal to. Okay, now let's look at our second graph. Our second graph was y is less than 2. Remember, just like the last one, this is one of our special pictures. This is a y means we're looking at the Hoy case because of the y, which means I've got a horizontal line again. Remember, horizontal lines go left and right. It's going to be at the number 2, and we'll only hit the y-axis. So it means up here at 2 on the y-axis, I'm going to have a horizontal line. Be careful. It's less than, not less than or equal to, so it's going to be a dotted horizontal line at 2. So on both graphs, I'm going to do a dotted horizontal line at 2. So I've got both of my graphs drawn upright. I don't have any shadings yet. I need to shade. That is the key behind the inequalities. How do I figure out the shading? I need to test a point. So let's figure out a point to test. Well, let's go back to our first graph. On our first graph, I'm going to pick, yay, I can still pick 0, 0. So let's pick 0, 0 to test. So remember, our graph for the first one was 6x minus 4y is less than or equal to 10. And I'm testing 0, 0 by plugging in 0 for x and 0 for y. Notice I'll get 6 times 0, which is 0, and negative 4 times 0, which is 0. And they're subtracted, which is just another 0. And on the other side, I have less than or equal to 10. So, is 0 less than or equal to 10? Absolutely. The question is, what does that mean? It works. It means the point 0, 0 works. So that means we're going to shade that side that 0, 0 is actually on. So that means I'm going to shade the side that 0, 0 is on for that first line. And remember, this is just my mock-up. So I'm going to shade the side that 0, 0 is on in my mock-up. I don't want to do anything on my final graph yet. Okay. Now I need to also shade my horizontal line as well on my mock-up. Well, remember my graph was y is less than 2. I'm going to test the same point. I'm going to go to 0, 0 and plug that in. So I'm going to plug in 0, 0. So remember, that means there's only something to plug in for y, so I'll get 0 is less than 2. Is 0 less than 2? Absolutely. So that means, again, the point works. So that means for the horizontal line, I'm going to shade the side that 0, 0 is on, which is the bottom side of the line. Okay. So I've got both shadings on my mock-up. The question is, where's my overlap? Well, where do I see the red and the green overlapping? I see it overlapping in this triangular shaped region here. So when I go to my final graph on the right here, that's the only part of the graph I should be shading in. So on my graph over here to the right, I'm only going to shade in that right triangular piece. And that graph is what is my final answer, where I have both lines, but I've only got the overlapping shading. Now let's add in one last example. What has been nice with all of these problems is that we've been able to actually plug in 0, 0 each time. Let's look at one where we cannot use 0, 0 as a test point. So let's look at one last example. And we'll be told to graph, let's see, and I'm just making this up, y is, let's see, greater than negative x. We'll just do one graph this time. So, first of all, how do I graph this? Well, it's already in slope-intercept form. So the question is, where do I start? Well, notice you always start out with the y-intercept, which is usually off by itself. Well, there's nothing there. So what that means is that your y-intercept, if there's nothing there, is just the value 0, which means I'm going to be going through the origin or special point. That's why I can't use it. Now, to get our second point, I'm going to need to use the slope. Well, our slope here is hidden. It's a negative 1. Remember, what's hidden underneath the negative 1 is just another 1. So that means if I use my slope as a rise over a run, because the rise is negative, it means we're actually going to go down 1. The run is positive, though, and then we'll go right 1. So we're going to go down 1, and then we'll go right 1. And then the question is, what type of line we're going to have to draw? Well, be careful. This is let's see, a greater than, not a greater than or equal to. So that means we're going to have a dotted line. So I'm going to draw a dotted line going through my 2 points. Now, the reason why this graph is different is because I cannot go through the origin. 0, 0 is not possible because my graph is already going through it. So I need to pick a different point. So I'm going to pick something that's clearly not on this line. So I'm going to pick something easy though. I'm going to pick this point, which is up on the y-axis. It's 0, 1, and I'm going to test that. Well, so let's do that down below. We'll test 0, 1. Remember, our inequality was y is greater than negative x. So I'm plugging in, let's see, well, an x of 0 and a y of 1. So what that does is give me 1 is greater than, well, 0 times the negative is still going to give me 0 on the right-hand side. So is 1 greater than 0? Absolutely. So my new point, 0, 1, yes, gave me something true. 1 is bigger than 0. So that point works. So what does that mean? Just like before, if our point works, it means we shade the side that the point's on. So we'll shade the side that the point's on. Remember, you get to pick the point. We just like 0, 0 because it's easy. You can pick anything you want. This is a good example of how and why. So we are done. We shaded the correct side. We just had to pick a different point this time.